1626 and 1628. If we do 1625 here, it should help you get both of those. So, yeah, because for 1625, I'm going to do both the rank correlation, right, and then do the t-test that we have to do also. So if we do both of these in 25, should get you there. So for 25, it says, do husband and wives like the same TV shows? Absolutely not. Oh wait, we actually have to do the test on here and see. I'm just telling you that my wife and I don't like hardly any of the same things. But anyhow, a recent study by Nielsen Media, a young married couple. No wonder they're young. We used to watch some of the same things. A rank of 1 indicates the best liked, and 14 the least liked. The results for one married couple are as follows. So it asks us to draw a scatter diagram first, which I don't think you guys have to do, so I'm not going to worry too much about showing that, but you guys kind of remember how to do that. It almost looks like there's correlation there, doesn't it? So we'll see how that turns out. That would have been my A. I don't think you guys have to do that. But B then says compute the coefficient of rank correlation between the male and female. That's this formula here. R equals, R is rank correlation, 1 minus 6 times the sum of my d squareds divided by n times n squared minus 1. Piece of cake. Yeah, I probably could have told you that, just off the top of my head without even having a look at the book, right? So anyhow, so we got the stuff. I don't know if this one, again, you should look. These maybe are downloadable, even though it doesn't show it. I sure hope they are. But I got the old male and the female things here, okay? And then D is the difference. So that's what the D stands for. There's the old difference, right? So that's just simply equal to the one minus the other. And you could probably do it backwards. It doesn't matter, because then we're going to square those, right? Equal to this squared. Okay, in both cases we could drag our formulas down, obviously. Okay. And then it says the sum of the d squared, so we need to sum that. That's what that little doodad deal there means, is the sum of. There it is, right there. Okay, 242. And then it says to take 6 times that. So let's do that, and then we'll have the top of this equation done, right? If we do that right here, we can just say this is equal to 6 times the sum of the d squared, so the difference squared, equals that. Now the bottom is my n, and my n is actually 14, right? It's the paired n, so I got 14 times 14 squared minus 1. Well, here's 14. Here's 14 squared. Okay, 14 times 14, and then I subtract. So I got 14 times 195, basically, is what it amounts to. But if we do it the right way, we say this is equal to 14 times, parentheses, 14 minus 1, and parentheses. Oh, I did something wrong. Oh, it's not 14, it's that 196. Let's try that again. Equal to 14 times, parentheses, this 196 minus 1. That looks maybe a little bit better. There we go. And then it's this divided by this. Sorry. So I got my 1452 divided by my 2730. This divided by this. And then I got 1 minus that. Should give me my correlation of rank correlation, right? Coefficient equals 1 minus this one here. There you have it, okay? And I got that over here, and I put in the whole long equation there, which person could do as well. I always find it a little bit easier to break that up. So really for your guys is 26, that's as far as you have to go, okay, is finding the R, using that equation there to find that R, okay? Then for the rest of it, it says for C, for mine, for 125 says at the .05 significance level, is it reasonable to conclude there is a positive association between the two rankings? So my alternate hypothesis, and you need to state these, there is a positive association among the ranks, and my null is that the rank correlation in the population is 0. Okay, so first let's go look up my t, and I've got 14 is my n, but I got two different samples, so it's 14 minus 2 is my degree of freedom. And if you look in your t chart, your guys is a little bit different, but my degree of freedom's here is the 12, then 14 minus 2, and I come along then until I come up with the one-tailed test, which this is because it was greater than, right? So 0.05 was my significance, and I come down here to the 12, so 1.782. So I'm going to reject the null if my calculated t-value exceeds 1.782. For you guys, it would be on Appendix B5 in page 734 to look up that t-value. Okay, so now I have to do this equation, which is the square root of n minus 2 divided by 1 minus r squared times r. Okay, so again, not real difficult math, so we got n minus 2, which really is my degrees of freedom, is equal to my 14 minus 2. Okay, we'll just do that part. Then the bottom part, 1 minus r squared. Okay, so that's equal to 1 minus, and my r, which I calculated right here, right? I'm going to put parentheses, this to the second power, in parentheses. Should work right there, I do believe. Okay, so that's the bottom part. So now I just got to divide the top part by the bottom part, so the 12 divided by that is equal to 12 divided by whatever, 15.3678, so that's before the square root. And then obviously I got to take the square root of that, and you guys know how to do square roots. So, but it comes to 3.92, and then I got to multiply that by my r up here, my rank correlation. What's that called? Yeah, rank correlation number. Okay, so my t, then my calculated t is equal to this square root value times my r. I guess I should have done the r first, but doesn't really matter. 1.83. It is greater than, so we can reject the null, right? And the null was that there was it was 0, right? And the alternate is that there is a positive association. So we reject the null, and we conclude that there is actually this positive correlation that we saw right here in our little chart. So there's 1626 and 1628 all rolled into one.